All right, so we'll jump in and get started. You guys should see the link out there from the welcome video on Tuesday. Hopefully everybody got through the academic policy quiz. Anybody have any issues with that? And then once you completed it, it showed introduction and basics, right? Cool. It's nice when tech works the way it's supposed to. Awesome. So in our introduction here, again, I'm just going to kind of scroll you through the stuff that's important for you guys to learn this particular week. So in the introduction, definitely read through this so you can understand your conventions, what's programming, the background of Python. I'm not necessarily going to cover that. The book does a really good job of explaining what those are and the different chapters that are in there. What I do care about out of here is you guys getting Python installed if you haven't done that already. So as it says in here, it's going to talk about downloading and installing Mu. We are not going to do that in this course. Okay. We're going to use idle for our side. It will talk about idle here. That's going to be the same way. And then we'll get into the interactive shell. So to get there, back in this section, if you click on this Python downloads, and you can download the newest version. Save this out here in downloads. And this should be about the same in all of your versions out there. So whether you're Windows, Linux, etc. If you are running Linux out there, note you don't want to overwrite what's already there. So you're going to install this beside it. Same way I'm about to do here on my laptop is I can either upgrade or I can do a new install. And I'm going to do a different install so you guys see the same path. So when you do click the option there for customize on this side, you'll see a bunch of checkboxes here. Great. Hit next. Hit next, and you actually should see an option for path, which it's not going to show because I already have it installed. But there should be a checkbox down here at the bottom of that installer. Let's launch that again. So instead of saying upgrade, it should be install. There should be a checkbox down here at the bottom that says add path, add Python to your path. You have to make sure you get that checked, or about halfway through the semester, you're going to run into some issues. All right. So for me, I'm going to have it installed just alongside because I have multiple versions of Python running on here and I need it for other projects. And if you miss that, like I said before, all you have to do is uninstall Python, reinstall it, make sure you get the checkbox, and you should be good to go. Yeah.
Which I'm confused. Which where's the link to download Python?
In the Blackboard shell under week 1.
So
getting back there here. So you come in, you're going to see this introduction in Python basics.
Yeah.
And then inside there, you have this Python downloads for installation. Just open it up. Yeah.
Also, the add Python to path is at the bottom of the first window. Not the last one. It has it right when you open the mixed people.
This one here.
Yeah, like when you first open it, the tick box for that is on the first screen.
Okay, yeah. It should be on that first screen. Mine's going to look a little different here because of the whole already having it installed kind of thing. But yes, make sure at the very bottom of that first screen you have path, and it should be checkbox.
What about Mac? I installed it and it gave me these. Do I have to like open one to like add to path or something? Or is that what's the process for Mac?
Did you run the installer?
Yeah.
As long as you run the installer, it should be added to path automatically.
Okay. So
on a Mac.
Okay.
Yep. The trick is when you go to open files sometimes on the Mac, you want to make sure you get it to associate with the newer 3.12. Otherwise, when you double click a Python file, it's going to open it up in 2.7 or whatever the underlying operating system Python is. What you don't want to do is upgrade the underlying operating system one, because the underlying Mac and underlying Linux relies on a specific version of Python. You don't want to overwrite that.
Okay.
All right, should be just about done installing here shortly. So while this is finishing up, take you back to the content. Down here, again, it's going to tell you how to install and do that, and you will get an interactive shell. And we're going to go through that interactive shell to see what that looks like. Other pieces this first chapter is going to tell you about is installing third-party modules. To do that in Windows, you're going to use what's called pip. And so if you bring up a command prompt after everything's up and running, and second, my bump. Okay, that should be back. On this side, you guys would do something like pip install and then whatever package that you're installing. All right. We won't do that till much further into the semester, and I'll tell you when you actually have to do that. But that is how you would go about installing that package. If you are on Linux or Mac, you may have to use pip3 install whatever's inside of there. Okay. That's usually if you have Python 2 installed, and you would have to specify specifically for 3. In this class, you definitely want to use the Python 3.12 that we're doing here. Don't try to run it in Python 2.7 or any 2.x code. It is completely different from 2.x to 3. All right. They have different mannerisms, different ways of running stuff. So please don't try to use an older version. Even within the 3 series, you want to make sure you're out 3.12. That way everything matches what you do in the class. All right. I don't know why this is taking forever to install today, but almost done there. When it comes up in your start menu, you can just start typing idle. All right. And then you will see this idle here. Now I'm already going to have that, so I'm just going to continue on, let it do its thing in the background. And that should bring up idle. We'll go ahead and launch idle. Pretend like that's already done because it won't matter for this purpose. Unless it complains because it's already trying to install it. All right. I'm impatient. Come on. All right, I'm gonna pause the recording for this moment. All right, sorry about that. So this is what you should get when you launch idle. All right, this is what's called an interactive shell. We don't typically use that, but it is nice if you're debugging or troubleshooting or wanting to work with an interactive shell, you can do that. In this class, we won't use this. We will actually write a script and then run the script. All right, when you type stuff in here and then hit enter, it will automatically execute whatever you just typed in. Right, that's what makes it the interactive shell. So for example, here you can see 2 + 2. This is going to be some integer, and then we're going to do a math operator and then another integer, and we end up getting 4 back as another integer. All right. If I tell it to print hello, it will then go ahead and print back to me hello. All right. And we'll talk about all these different functions and stuff. But the big thing I try to emphasize here is you will never use this for your homeworks or anything else in this class. What you're going to use is a script. So you're going to go up to File and then New File up at the top. And that should bring up this window. All right. So not this one. You want this one. Sound good? All right. So in this file, this is where you're going to type your commands. And then once you get done, you're going to go up to Run at the top, Run Module, execute the script, and see if it runs. Okay. When I test your guys' code, I'm not going to be running the .py file on the command line. I'm going to be running it in idle. All right. So why is that important? If I run your code from a command prompt, it's going to run it on the screen and then close it right away. I'll never see the output, right? It executes and then closes the window when you run it. So when you guys want to run and test your files, always open them up in idle, come up here to run. And then when I run it, it will actually run it back here in this back window, the interpreter. So for example, if I do the same thing, print hello, and then I tell it to run this, the first thing it's going to do is ask to save your file. You're going to hit OK. And then you need to save this somewhere. Now, by default, it's going to try to save it in Python 3.12 in this folder. Do not save anything in this folder. All right. It will cause you massive headaches later in this class. Please don't do that. So create something in your documents folder, wherever you want to save your stuff, put it in there so that you don't have issues. So for me, I'm just going to do the example in this class, put it in my 360 folder, and I will call this just example. And you can see that it names it as .py. I hit save, and then it's going to go ahead and run it. And you can see that it's running this file, and it's going to call it hello and then print it out. When you see this prompt again, that means the script is run, and that's the end of the script. Anybody got any questions on how to operate these files? almost somebody messes this up in the first week. All right. If you submit me just this as a copy and paste for your first homework assignment, that's not what I'm looking for. I'll delete it and resend it back to you and tell you to send me the script. What I'm looking for is this side. It's this .py file. So you don't have to copy and paste this out, and please don't copy and paste it into Blackboard. Just submit this example.py file. So for example, if we were to go to this week's homework assignment at the bottom, you would click on assignment 1, upload file, browse file, and then you would go to this one here, which is this class, the one I just created, 360 and example.py, and then you would just simply hit submit. All right. You don't have to add any comments or do anything else in there. Just hit submit and that would be your file. Now, obviously you don't want it to name example.py, right? Everybody should be naming it with the right proper structure. So if you come back here to learning modules, look at this assignment section, it should be like this. All right. Remember, at the top of your assignments, you should always copy and paste this in. Super simple. So I would come in here, for example, if I was going to start a new homework, I'd come in new file, copy and paste this up at the top, and I would replace this line with your name, not Jason Zeller. I'm Jason Zeller. You guys put your name. I know that sounds silly. You'd be amazed at how many students put my name up there. Okay. Well, I want your name on the paper, not my name. All right. I'm not conceited enough. I don't need the instructor name on the paper. We're good. On the assignment number, simply replace it. All right. So assignment 1, assignment 2, assignment 3, assignment 4. You have 4 homeworkers in this class. It's really that simple. When you get to your midterm project, you will call this midterm project. When you get to your final project, you call it final project. All right. Same way in the file name. So for example, this first homework assignment, I would go to file, save as, and I would save this as your name, Jason Zeller, assignment 1.py. All right. You could also call it homework 1. Either way, that part doesn't bother me. The thing I need in there is your name plus the assignment of whatever it is. And again, that saves me a ton of headache because if you guys all call it assignment 1 or homework 1, it causes a lot of issues on my side. All right. And it takes me longer to get through, grade it, get you guys back the right grades, that kind of stuff. So I would hit save here. And then at that point, I could go ahead and write my code, execute, do that kind of stuff from there on out. All right. Anybody got any questions on that side? I know it sounds like I spent a lot of time here. It's because that's the number one thing we always have issues with in week 1. So I like to cover that and make sure. Okie doke. So if we go back into week 1, this introduction to Python basics, and now we're going to take a look at chapter 1. All right. And there's a couple things that we want to know here. So that interactive shell that you were looking at is called the REPL. All right. And what that stands for is read, evaluate, and print loop. And so it's going to read whatever I typed in. For example, if we go back and look at our REPL, we have the read 2 + 2. When I hit enter, it's going to evaluate. Then it's going to print it out to me and then loop and be ready for the next command coming in, which is exactly what we did up here. All right. We're again not going to do that for this homework assignment, but that's, you guys need to know what the interactive environment is. All right. So when you type expressions, you're going to see this here. And again, when it tells you to start up mu and stuff in the book, just run idle. Easiest way to get there, you hit start, type idle, it pops right up. When you look at your files in your file explorer, for example, I'm going to pull this up what it would be like in Windows. So if I go to where this file is stored, you will see this homework assignment. You would right click on it and you would edit with idle. Now, if you guys are on Windows 11, you're not going to get this very advanced pop-up menu right away. You guys will have to click on the show more down at the very bottom of that. Then you would see this menu that you see here. All right. If you're like me and you're old school and you just want to do it automatically, you can tell Windows to do it automatically like mine. You would go to this edit with idle, come down here to the right version. You should only have 3.12. I have multiple for running other classes. So we run 3.12 and you will see it will pop right up here for you to edit. All right. What you don't want to do is come in here and double click. If I double click, it's going to pull up a command prompt and then go right away. Okay. Everybody see that? If you actually double click this, it's going to pull up a command prompt, run the code, and then it's immediately going to close because there's nothing telling it to stay open or do anything else. So if you're trying to edit this or test this, don't do it that way. Open it up here in idle, go up to run module, and then you will see it execute on this screen. Now you'll notice nothing executed, right? That's because we didn't tell it to print or do anything else. What we have up here are called comments. And so when you tell me, or at the beginning of a homework assignment, I say your initial comments, that is these 3 lines up above. When you put a hashtag up there and then anything after that, that's what we call a comment. The code will not execute anything that's in that line. All right. It's a great way for you to literally comment your code, which is very important, as we'll talk about. But it's also going to basically skip over it at the point it compiles and actually runs the code. It skips all those comments. All right. It's purely there for you to be able to read and know what's going on. Okay. If we type anything, you're going to see a bunch of errors, and just know in this class, you're going to have a ton of errors. The beauty is in Python, it's going to tell you what line number it broke on, and it's going to tell you roughly why it broke. If anybody's ever done C, you know that that is like a miracle because C doesn't tell you anything, right? Program crashed. Okay, I guess I'll go figure out how to debug that for the next 4 hours. In Python, it's going to literally tell you which line you have an issue on. So if we come up here in the shell, or in our homework assignment, and if you go to options, you can say show line numbers, and it's going to put the line number over here on the left-hand side. All right. So I encourage everybody to do that so you can see what line number. Now, if you're using a fancy IDE and some other stuff in there, you're going to automatically see that. But in idle, which you should be using for this class, you're going to see them that way. You'll also notice wherever your position is out here, down here in the lower right-hand corner, you'll also see what line number you're on as well.
Wait, how do you see line number again?
If you go to options and show line numbers, and then down here in the lower right-hand corner, you would also see it regardless of whether you have that turned on. But that allows you to see those line numbers. So if we have an error, for example, I just type in some gibberish and I run this code, you're going to see I get red text. All right. Red text is the bad thing in this class. If I run your program and I get red text, that means it crashed. Okay. We want to make sure that you never get red text. Now, in homework assignment 1 and 2, I can put in gibberish into your programs and they're going to crash, right? Because we haven't learned how to make sure that whatever somebody types in is valid. So if I type in gibberish and it crashes, that doesn't get counted off in homework 1 and 2. And 2, it starts to get where you can start to verify code and that kind of stuff. Beyond that, then we actually teach you how to make sure that whatever is typed in is valid and verified. I call that sanitization. So if you hear me use the word sanitization in this class, what that means is I took your input, made sure it's valid input before I start off with the rest of your code. And we'll explain all that when we get into that part of the semester. All right. So just for now, assume if you have somebody type something in, that it's always what you asked for. So if I ask for an age, they typed in their age, not their name. All right. Because it will break your code if they type in something else for the time being. So if you get an error, you're going to see this, and it's going to say trace back. What you're looking for is this line number. All right. If we go back and look in our code, we can see that's on line 7. And over here, we're going to get, in this case, a name error because whatever this blah, blah, blah is not defined, meaning it's trying to run this as a function. It's not been defined for us. And of course, it basically means you just have gibberish on that line. All right. You're going to get different errors for different things. The good part is this is where you can use that information to look that up. All right. Again, you will get lots and lots of errors in this class. If you get constant errors and you think you're failing, you're not failing. That's completely normal. As a matter of fact, you're going to see me screw up every single time in this class. You know what you're going to see me do though? Go back and read this. We're going to explain what that error is, and then we're going to go and attack it. And that's why all my videos are going to have errors in them. I don't edit the videos to make it look like I'm perfect because that's not real. All right. You guys need to be able to figure out how these errors work so you can go back and fix the code. Lots of students get frustrated in the first week or two. They're like, it's constantly breaking. Yeah, that's fine because you're learning the syntax. Until you learn the syntax, you're going to get errors. It's totally normal. All right. Anybody got any questions on that part? All right. Don't get frustrated with it. Read it. It's going to give you some information. You can always Google this kind of stuff. It will help you along with what's going on. Yeah.
someone, I can't remember who, I think it was Kevin at a what's it called, that orientation. He said that we could use ChatGPT. He said that you were okay with us using ChatGPT to check our code, but not to make code.
In the first class, in this class, not so much. In the advanced class,
Oh, yeah,
yes.
sorry.
Yep.
you covered that yesterday.
Yep. In the advanced class, you guys can use it, kind of play around with it. In this class, you can use it to help diagnose some of your code. What you don't want to do is have it write into your code because it's going to write super advanced, right? It's not a beginner. So it's going to be thinking at a high level and really minimizing code. You guys won't be there yet, and I wouldn't expect you to be there yet. All right. And really what you need to know there is don't just go plug this into ChatGPT and get an answer back from it, because you have to learn how to diagnose your code.
Yeah.
At some point, when your script gets big enough, ChatGPT is not going to point you in the right direction. You will think it is, and it will fix the little issue, but then it's going to break because it doesn't know anything else about your code. So it's smart, but not super smart.
It'll get there one.
Yeah, there's stuff out there that will help you with it down the road, but in a beginner class like this, it breaks more than it helps.
Okay.
All right. This table 1-1 is important for your homework assignment. So this is your math operators. Everybody took math or college algebra or whatever else back in high school, right? So you know what math is. In this case, for us, we call them math operators, and it goes in the highest to lowest order of precedence. Does anybody remember what that's called from high school?
Order of operation.
Order of operations, or PIMDOS, or whatever you wanted to call it back then, right? In this case, they call it order of operations or precedence. So anything that is a double asterisk is a exponent, and it will always be executed first, and then it will work its way down this chart, okay? With plus sign being the last one, then subtraction, multiplication, etc. So these are the symbols you would use in order to do math operations. So for example, if we were to say 2 + 3 × 6, you will end up with 20, because it will take 3 times 6 first, giving us 18. Then it will execute the 2 + 18, giving us 20. Okay. If we put brackets around it, well, then it will obviously execute the code first in the brackets. In this case, we use a parentheses, not brackets. So excuse me, it's parentheses. Brackets mean something else. So 2 + 3 is going to be 5. Then we multiply that by 6. We get our 30. Okay. This will always show you great examples of an interactive shell and how it's working. You can apply the same thing in the scripts that we do in this class. Now, the great part about Python is you'll notice even the errors that come out are pretty human readable, right? And your code executes like it's in English. So if you're telling it to do this, you can do that. Whereas C and some of those, they get a little different in how you go about it. So Python, as they call it, Pythonic, it just means that it's more human readable. And that's why it's being adopted at a very fast rate across a bunch of different people and around the world. All right. Next part we're going to talk about is data types. All right. There's 3 main data types you'll work with in this class. You have the integer, the floating point, and the string data type. All right. So integers, you can think of those as whole numbers. -2, -1, 0, 1, 2, 3, 4, 5, etc. All right. Floating points are going to have some decimal point. So 1.25, -1.0, etc. Note that -1.0 is different than -1. All right. When you add a decimal to it, and even as if it's a 0 afterwards, they are not the same thing. Those are 2 totally different data types. All right. Strings are always going to have single quotes around them, or double quotes, depending on what you're doing. But those quotes signify that it is a string coming in there. So this is typically where you would have letters like A, AA, AAA, words, etc. Whole sentences, etc. would all be in a string. I can also put the number 11 in a string. That is not the same thing as the integer 11. The moment I put quotes around it, it is now a string, aka ASCII text, versus an actual number I can do math on. So for example, in that piece, if we come in here and look at our shell, and I say 11 + 11, and I hit enter, it knows it can execute math on those 2 integers. All right. If I do 11 + 11.0, it can calculate that. And in this case, it will give you back a float, right? Because we have that decimal point. If I say 11 + 11 in quotes, I'm going to get an error. And this is the most common error you guys will see on your side when you're playing. So you're going to see a type error, and it's going to say unsupported operand type for int and string. This means that basically you try to add an integer and a string, and there's no way to do that, right? You're literally adding text versus a number. Does everybody kind of understand the difference between those? All right. We would have to convert that string over to an integer, or we would have to convert that integer over to a string in order to put the two things together. If we're doing it as addition, we need to have it as either an integer or a floating point in order to do math on it. We can't do math on strings. Yeah.
Is Python color coding what it is, the blue and the green?
Yes, it is. So you'll notice on the black side of it, it would be an integer. It would, when it does a response in the REPL, it's going to be blue. But yes, the green part is really what matters, and that indicates a string. That's another reason I try to have everybody use idle. So when you guys are actually typing that over here, we would see the same thing. So if I say 11 plus 11, you'll notice it's just black text. If I do 11.0, it's still going to be black, but the moment I put a string in, you'll see it goes to green. Right? Great question. Okay. So when we say something like that, or say we forget to put the end of that parenthesis on there, and I go ahead and run something like this, you're probably going to get an error as well that says an undeclared string. Whoops, and I clicked run because I'm used to doing that. You'll get something like this: undetermined string literal detected at 9. What that means is you forgot to close whatever this string is. Okay. For now, we're going to use single quotes. You could also use double quotes, and we'll explain why you would use double quotes later. Just know that if you see me in this video, I use whatever my finger types at that point in time. It doesn't matter which one's which. The double quote is technically better because what that does is later on we'll learn about escaping characters. But say you have a contraction like Jason's pet, right? If I put two single quotes in there, it doesn't know the difference between the apostrophe and a single quote. So to fix that, we would use double quotes like that. And we're going to talk about that, but it's like a few weeks down the road. But I always tell people that early because my fingers do whatever they want to do when I'm typing this. And some people are like, why'd you use a single? Why'd you use a double? It's because that's whatever my fingers did at that time. All right. Either one is perfectly fine. Double quotes being the best because it would automatically help you out if you happen to have apostrophes in there. All right. Which takes us to string concatenation and string replication. So we can do math on two integers, right? 11 plus 11 gets us 22, right? If we want to take two strings and quote, add them together, in other words, we want to put them together, that's called concatenation, all right? And those of you that played with Excel back in the day know there's the concatenate function, right? We want to take two cells, put it together. This is the same concept. So if we have the string Alice and we say plus Bob, and those are strings because they have single quotes around them, we are going to get the result called Alice Bob. Notice how it squished it together, right? There's no space in there. If you want a space, you would have to either say Alice plus and then a space in single quotes plus Bob, and that would get us Alice space Bob. Yeah.
What's the fun like? Okay, so I'm guessing then it's later. What's like the practical application of Python? Like, what does it do?
So a lot of what you will do with Python is be able to write scripts and codes to automate the boring stuff, right? That's literally the name of the book. And that's because a lot of the stuff you do mundane in life, you can actually script with Python to do that and have it automate that kind of stuff for you.
Okay.
So that kind of leads back into the story I always give on this class. And I mentioned it, I think, on Tuesday. I got into Python because I was doing a very mundane task of sending out usernames and passwords for every conference I went to. I'd have about 50 instructors that would come attend my workshop. I'd have to give out all those username and passwords. Then a week later, trash all those, resubsign them on another system and put them across, right? So I used Python to automate that from the back end so that I didn't have to touch that. I hit go, it ran a script, it sent it out to everybody, including emails, the whole 9 yards. I didn't have to touch anything. And it saved me literally hours in my day. That's most of it. A lot of it, and what most people are going to do is crunch data. At some point, you have to crunch data in whatever job you're in. Doesn't matter what it is. So you get handed a PDF document, you get handed an Excel sheet, whatever it is. You need to figure out how to take this data, massage it the way you want it, and stick it out. It could be numbers, it could be letters, it could be all sorts of stuff. Python is the most human readable way to do that. Now, yes, we have fancy tools like ChatGPT and all those to handle that. Well, guess what ChatGPT runs under the hood?
Python.
It's all Python.
That's cool.
Every bit of it runs Python under the hood. So when you tell it to go do something, even math, 2 + 2, it literally runs that in Python underneath the hood, right? And Python's extremely versatile. You can make it do little stuff. You can make it do full-blown web applications, which is what we develop in the advanced course. It's a very flexible Python. It's a very flexible language, computer language. All right. So this is string concatenation, where we're taking 2 strings and quote adding them together. Now notice we're using the same operator, the plus sign, but in this case, this is not a math operator. All right. This is string concatenation when you see it this way. You are taking 2 strings and putting them together. That's why I don't say add them together, because I don't want you getting confused that it's not a math operation. It is a string concatenation. We also have string replication. So say I have the string Alice and I want this generated 5 times in a row. I can simply say Alice, multiplication symbol or the asterisk 5, and it would give me out a string that looks like this with Alice 5 times in a row, all smashed together. All right. If I say Alice times Bob, I'm going to get an error because I can't multiply the sequence by another string. So this only works with a string, the asterisk, and an integer after it. Okay. Anybody have any questions on string replications, any of that kind of stuff? All right. We're going to talk about changing between the different ones here in just a little bit, but for the purpose of this, this is what you'll need on that side. All right, so that gets us down to the basics of all programming languages, and that is using variables. So right now, what we've been doing in this is we've just been using numbers or something like that. A lot of times we use variables in order to store information that we will use later on. So for example, if I have the variable called name, and then I want to set name to Jason, all right? Now, if you come from another language, you guys often have to declare those at the top of your script. You do not do that in Python. You just declare them at runtime, right? So if you guys were running like a C language or something, I would have to say name equals null or name equals an empty string. Oops, something like that. You do not have to do that in Python, all right? You only have to declare your variable when you're about to use it. So if I say name equals Jason, then down below here, I can use the print function, which is going to tell it to print to the end user, print the name. And then if we run this, it will execute those. Now, Python executes code from the top down. So starting at the top, moving its way down, it's going to go line by line all the way through. So it sees the variable, defines it and declares it and puts it in its memory. And then from there, I'm telling it to print it. Okay. If I change that variable, name now equals Jack, and then I tell it to print the name once again, you will see it prints out Jason for the first time and then Jack for the second time. All right. Now, I did not change this variable name when I did this part here. I actually overrode it and declared a whole new variable called name, but I did not change the variable. I wrote a whole new variable. And that's important later on when you're doing some things, but there's different numbers or UUIDs that go to each one of these variables. At the moment I replace it, it is completely a whole new variable, maybe called name, but it replaced the old one that was in there. Anybody have any questions on how variables work? So I can name this anything over here I want on the side. If I just call this Apple and say Apple's equal to Jason, well, then if I want to print this, I should get this error, right? And why do I get this error? Well, on line 9, it's trying to print name, and we can see that here, error on line 9, and it says name is not defined. Well, that's because we now just have Apple defined before this is executed. Therefore, it has no clue what's inside of there. But if I was to put this above that line, it would now go ahead and print Jack, and nothing would ever happen with Apple. We never print it. We never do anything. It's defined. It's in memory, but it only runs through the program when it's executed, and then it's gone. All right. Anybody have any questions on how those variables work? And just so you know, the names that I use in here are typically my kids. So you see a bunch of random names, it's that. Every now and then I'll steal a name out of the class. Okay, assignment statements. Assignment statement is what we just did. We take some variable name, we say it is equal to with the single equal sign, and then it's equal to something. So in this case, we said that this variable name Apple is assigned Jason. Okay, I could very well say something like age equals 40. And now it's equal to an integer on this side. If I try to say print age and run this, you can see it will go ahead and print it out to the screen, 40 and Jack. All right. If I try to concatenate this age and this name, for example, print name plus age, we will get an error because I cannot concatenate a string and an integer at the same time, right? Remember, string concatenation only works with 2 strings. So I would have to convert this number 40 over to a string in order for me to print it out. Now to do that, we have 3 functions. We have int, and you'll notice that it's the name of it in purple. And then you have the 2 parentheses on the outside of it. We have float and we have string, str. All right. Those 3 functions are going to be able to convert whatever you put on the inside of those parentheses to whatever you're asking it to. So for example, if I say int 40, it will convert 40 to an integer. Well, it's already an integer, right? So let's do 40.0, which is a float. It will then convert this over, but I need to store that in something. So I would say something like num1 equals int 40.0. That will take 40.0, convert it to an integer, in this case 40, and then num1 is now equal to 40 in our code. And I can use num1 anywhere in my code that I would want to use the number 40. Okay. On a float, same way, we could say something like num2 float, and we could pass in an integer like 40. And at that point, num2 would become 40.0, right? As long as whatever is in here can be converted, you can convert integers to floats, you can convert floats to integers. What you can't do is convert all strings to the other 2, right? So strings are what's called the universal one because they can be equal to everything. So for example, if I say my string equals str, if I put 40 in here, it will convert it to parentheses, or I'm sorry, asterisk, single quote, 40, single quote is what it would convert this to. And we can test all this just by printing them. So if we do my string, and if I come up here and say print num1, print num2. Notice that when you use the print function, it's 2 parentheses, you put inside of it whatever you want to print out to the user. And I can even put straight text if I wanted to. So if I said print, next is the string, I can put whatever I want, something like that. Notice I use double quotes. You can use double or single. It doesn't matter when you go in there. When I execute this, we'll look at this line by line. So I'm going to do this side by side here. The first thing it does is see my apple. It sees my name. It sees my age. And then it's going to do a conversion of this 40 to an integer. It's going to do this 40 to a float. And then I tell it to print. So if we look here, the first one is 40. That's because it took this float, converted it to an integer. Then we told it to print. It took this 40, converted it to a float, 40.0. Then we told it to print. And then this, the next is the string. So it just printed this line. Then we have this my string is now equal to string 40. And I told it to print that, which it worked just fine. And then we had this old one down here where we tried to concatenate a string and an integer, and it still failed. So if we took this out, we would no longer have that issue. But what we could do with that age is we can convert that over to a string, right? Right now it's an integer. We could convert that to a string. So if I say str age, and you'll notice at that point, it will convert it to a string. And if I rerun this, it will then concatenate Jack, the name, with the string of whatever age was, in this case 40, and so we get Jack 40. All right. So you can convert an integer and a float to a string, because anytime that would work, right? You can convert sometimes a string to an integer or float, but it has to be in the right format. So for example, if I had this string here of say 40, and I want to convert that over to a integer, I would say int my string, string, and it would convert it over to an actual integer 40 that I could then do math with if I wanted to. All right. If I put something like 40 ADF or whatever else after it, it can no longer convert that to a known integer, and therefore the program would fail at the time it tried to run this part here. And we can see that if we actually run this code, it's going to die on this, and you're going to get this new error that we haven't seen yet. It's a value error, and it says invalid literal for int with base 10, then whatever this string is. What that's saying is I can't convert that to a number. So whatever you have in that string, I can't convert it to a number. And it can't, right? 40 AFDF has no clue what that is, and it can't convert it over to a number. So if you see this error, all that means is somebody typed in text, whether it was letters, numbers, whatever else, and it can't convert it over to a number. I know this is a lot of information. This is why I record classes. All right. You guys can go back, rewatch the video, kind of go back and forth, use it as you play along, that kind of stuff. Anybody have any questions in here? Again, don't be afraid to ask questions, because somebody out of the other 75 students is going to have it. Yeah.
So when you're doing this, do you want us to literally follow along and type everything you're typing? Because you're going kind of fast.
You can, and here in class,
Yeah.
you can if you want, or you can just use it to follow along and ask questions.
Okay.
However you want to do it. Yep. I know I talk a little faster in here, but that's why I record it, so that you guys can easily play it back. And that's why I tell you, you can go back at 1.25 speed or 1.5 speed, so that it speeds you back through everything I'm doing. Okay. Let's see here. So this is going to give you that same demonstration. And this is I like to do live coding. That's why you see me actually doing coding, not just reading this in the book and saying, okay, good luck. Like, you're going to watch me make errors. You're going to watch me do live coding through everything in there. Now, those variable names we talked about, there are rules as to what we can call those things, right? So I called things like age and name. I just randomly picked those variable names. In this case, I have num1, num2, all right? It's best that you name your variables something that actually mean whatever they are. So num1, num2, not so great. Age, child's age, her age, his age, whatever you want to put in there will mean more to you in your program when you use that variable name later on. Because num1, num2, that isn't going to make much sense to you later down in your code. Right now, we have 31 lines-ish of code. Actually, we only have like 10. When you have 1,000, num1, num2 isn't going to mean anything to you. All right. So make sure you are actually using valid names. Those names can be anything like this, where they always start with a lowercase letter. Okay. It does say if you do all caps, that's fine, but you should always go with the lowercase letter. All right. Python will accept it if you do an uppercase letter. Just know that that's going to cause some confusion at the end of this course when we do object-oriented programming. So it's much better that you always do lowercase letters. So you can do something like current underscore balance, but you cannot do current hyphen balance. Okay. It'll throw an error if you try to do that. You can do camel case, in which case you start with the lowercase. If it's a 2-word thing, you can use a capital B. This is pretty common and widely accepted in industry. You cannot have a space in between there. Okay. It won't accept it. You cannot start with the number. For example, for account, but you can have something like account for, as you saw with num1, 2, 3 that I did before. You can start with an underscore, but you can't do a number for obvious reasons, because if we did a number, it would be a what? Integer, right? So you can't make the variable an integer if it's already an integer. You could do this. I don't really recommend it unless there's a real need for doing something like that. You generally want to stick with these top 3. Okay. You can do all caps if you want, but you cannot use special characters like a $sign. And you can do just string here, but you cannot use special characters like single quotes, because if we did that, it would be a
string.
string, right? So there's obviously some characters you can't use inside your variable names. That's because they have some other purpose inside of Python. So generally, don't use special characters. If you have something like total sum that you want to do, it's better off that you just do a camel case version of that, where you start off with lowercase total, do a capital sum for S on here, and then UM on that side.
Can we do underscores? Like the total sum has an underscore in it?
You could, yeah, you could do like this one. Yep. Either one of these two here is acceptable. All right. If you try to do this and it doesn't work, guess what? You're going to get some red text on the command line saying, hey, that's not valid. Okay. Simple fix. Note that everything in here is case sensitive. So on your homework assignments, if I say using the variable name, my input, all lowercase, and you give it to me with a capital M, that is a completely different variable and I count off the points. It's not me being mean. It's because it's a completely different variable in Python. So lowercase spam, all capital spam, capital S for spam, and S, capital P, lowercase a, capital M. Those are all different variables inside Python. It is extremely case sensitive on everything you do. All right. That will also give you headaches in your code. So if one time you capitalize it and another time you don't, and you can't figure out why the code's not running, it's because those are two different variables and it has no idea what you're talking about. So when I grade this, or I grade your homework assignments or your quizzes or your midterm exam, if it's not in the right case, it's not me being mean. It's because it's a totally different variable name. All right. It has to be exact on that side. All right. You're going to see this in variable names. It's saying it uses camel case instead of underscores, something like look like this versus looking like this with underscores in it. It doesn't matter which one you do. Technically, PEP 8 compliance says that you should be using underscores, so it's okay. I honestly prefer camel case, much like this gentleman here, Al Swigert, that wrote this book. But if you're going down the road, you could probably use underscores. That might even be better for you. This is why when you name your homework assignments, and you guys have probably done this in Windows, where you actually write Jason space Zeller space assignment 1 and hit enter, right? That space in there will really upset any programmer. And that's because we have to then go back and change things around because you used a space in it. We love when you use underscores because then it's a full-on ASCII character and we can do that. So be in the habit from here on out in your life, when you name files or anything in Windows, Linux, whatever, use underscores instead of spaces. All right. Trust me, it will save you in this class later on. When you guys interact with files, you're going to go, I can't believe somebody did this with spaces, because it's going to take you an extra 20 lines of code to fix that. And where you could have just done underscores and everything would work fine. All right. And that's also my piece to try to get 75 people every generation to stop using spaces in their file names. Like, please stop. It will cause chaos for people down the road. All right.
So if you ever want to be passive aggressive, just send them these spaces.
Yeah, you could do that. You could do that if you wanted. All right. We are going to get to our first program. All right. So let's look at this program here. And by program, all that means is we have our script. And honestly, we've already been doing that already. We have this first quote, homework 1 here. And I've been running this. When I run this, it is a program. We are executing a script. The code executes and runs on the screen. So if we look at this first one here that they gave us, we have a comment that says hello, ask for a name. And so then we have a print on down the line. I'm going to skip this because I'm just going to do our homework assignment. All right. Okay. Similar concept. It's very titled into there. It's also going to show you things that I've already showed you in this piece of it here. As I mentioned before, the hashtag and then anything after that is called a comment. I can do comments in a couple different ways. So for example, up here, I start the line with a comment and then type some text. If I have something like this, I can also do a comment and then type whatever I want after this. It will still execute this part, but the moment it hits that hashtag, it will no longer execute that. So this is called an inline comment versus just a comment statement. Okay. You can do either one of these. I absolutely despise these and you will too. All right. The reason I don't like inline comments is if I want to copy and paste this to another line, say I just wanted this part, I copy and paste, that works well. But if I try to move this whole thing a line or I'm trying to move stuff around, inline comments will break everything and it will severely frustrate you when you're trying to figure out why it's not working. So I strongly recommend you don't use inline comments. Instead of using inline comments, what you should do is take that same comment and put it right before whatever you're trying to do. And then go ahead and have your code underneath of that. So you would say something like, for example, in this homework assignment, we want to use the print statement. Actually, I'll show you that. Let's do that now. So let's go bounce back to the homework assignment. If you go to these homework assignments and you copy and paste this part. So we're going to grab every single one of these lines, hit Control C, go back to our homework assignment, and then paste them in at the top. All right. I recommend you come back, you put a hashtag in each one of these. And so now you know what you need to accomplish in this homework assignment right then and there. All right. We can do this, just give us a little bit of space if we want, but it all works the same. So for my homework assignment here, remember I need to change my name. So I'm just going to do that here. Like that. I have my assignment 1. And then the reason I have you do it this way is if you press enter under here, well, then you can execute the code that would get you that point from up above. So for example, this first one is initial comments. Well, guess what? That's these 3 comments up here. So we're just going to let that one slide. We already have that. The next one is going to be 2 points. Now notice this rolls off to the end. You want to make sure that when you write lines like this, that it really doesn't tail off the screen like this. Yes, you can move this over, but as you work on different size monitors, that's going to cause a problem. So it's typically 80 characters wide is all the further you want to go. If you click here, for example, at the end of this, my input, right? I look down here on the lower right, you're going to see that that says 82, right? That means I'm at column 82. I'm past 80, which means most people, when they run this, it's going to run off the screen for them. They're not going to be able to see it. So what I would recommend you do is you can wrap this around. For example, this one here where it says this input may be used, just simply hit enter, wrap it around to the next line so that we can see it. Everybody get that? When you're printing multiple lines, and we'll learn how to do that with multiple line comments and stuff like that later. For now, try not to have it run clear off the side of the screen. It makes it hard for you to read as well as for me to read and anybody else that may be executing your code. Which brings us to the importance of comments. You have to comment your code. As a matter of fact, I give you points or take away points for you not commenting your code. The reason is if you're a programmer at a building or, whatever organization, and you don't comment your code, I have no clue what you're doing there or what your thought process was when you wrote that line of code. So 4 years down the road, when you've left and moved on to other things, I'm coming back to look at your code going, why did he do it that way? All right. The more you comment, the better it is for everybody and yourself and your company. Guess what? It doesn't have to take somebody else reading your code. When you're working on your midterm project, you're going to be 1 week working on this section, 1 week working on this section. You come back, look at your code and go, why did I do that? If you didn't comment it, you'll have no clue why you did it. All right. So use it like notes. Write notes in your code so you can remember why you did what you did. Everybody got that? Trust me, the more you comment, you will appreciate yourself for it. Especially when we get to the final project, because you can actually convert your comments over to some of our logging statements and something else. If you wrote lots of good comments along the way, you've done half the work already. You will really thank yourself down in the final project. All right. So just get in the habit of doing that right away. You can never over comment. I say that there's a lot of times where that's really hard to read because now you got too many comments. Don't worry about that. Over comment in this class. All right. It helps me know what you were thinking. Or if you have issues at this point in the code, just write, I have issues here kind of thing, right? For example, I write to do, fix this next line, whatever's there and whatever's broken. If I use something like the word to do in all caps in there, when you become big programmers, the IDEs will actually scan for the word to do and then pull all your to-dos down in a checklist for you. So you can easily go back through your code and say, oh yeah, I got to fix that, and that. You don't have to search through thousands of lines of code to figure out what you forgot. So again, if you get in these habits, it's a whole lot easier on yourself when you're doing the advanced projects and stuff like that. Okay. So in interest of time, we're going to move right on through that. So this first 2 points is going to be use the print function to print a welcome and prompt a question to the user. All right. So we have been using this print function like this. You'll notice when I type the word print, it's going to bring up this little yellow box. All right. This yellow box is going to give me information about what this function's doing and the values or the arguments I can pass to that function. And we'll talk a lot more here next week when we actually start talking about functions. But for now, with the print statement, all you need to know is anything I type inside of here, if I type ASDF and close it, it's going to pass any variable I called ASDF into the print function. Well, do we have ASDF in this? No, right? So it's going to fail. If I wanted to print text out, I would simply pass a string to it. For example, this string, and then hit enter, it will go ahead and execute and print that screen out. All right. If I have a couple strings I want to print like this, and maybe I have something like name equals Jason, and I say print this string with a space at the end and then my name, it's going to try to concatenate those 2 strings together and then print it out. So if I run this, you'll notice it says this string Jason. Why did it do that? Because I had a space here at the end and it would concatenate everything out. Another way of doing this would be like the first string that I wanted to print, comma, the next string. If I do that, I will actually end up with 2 spaces here. And the reason for that is because I had a space at the end of this. And if you go back here and look at my print statement, you'll notice that it separates all values I pass to it with a space by default. All right. So this sep equals a single asterisk space, single asterisk. That means I'm going to separate any values you pass to me with a space. Okay. And by default, it's always going to end with a new line character, which means it's going to print onto the next line. So it's going to print this on one line, and then it's going to wrap and start printing on the second line or whatever you tell it to do after that. This will be important later on. Just know for now, what that means is if I print just like this, it's going to print a space of an empty line below it. So if I say print hello and welcome to my program, right? And then I want a space after that, I would just do a print with an empty brackets and then print what is your name? Okay. So if we just look at this part, let's get rid of this name because we aren't that far along. We simply run this project. I'm going to again run this side by side so you guys can see it. So we hit run. And over here, you can see that it executed this code. It printed the first line. I told it to print an empty line. That's what this does. And then I told it to print what is your name. Okay. So this gets us the first 2 points. We're going to use this print function to display some kind of welcome. That's here. You guys can do whatever you want here. And honestly, have fun with it. Like if you're a character and a jokester and put it in there, by all means, that actually makes it more fun when I grade it. Okay. What I don't like is don't be perverse and do other stuff that you wouldn't want your mother or grandmother to see. All right. I've had some students for whatever reason go off the deep end. I'm like, I can't believe you turned that in as homework assignment. Don't do that, please. If it actually is misconduct and everything else, I have to turn it in. So please don't do that kind of stuff. I don't know why those students would insist to do that, but they did. Please don't do that. Okay. So we have this part here where we print a welcome and then we ask a question with a print statement. Now we want to gather input in from this user. So we would use a function called input. So to use input, what we need to do is the next 2 points down here, by the way. So let's bring that up. Use the input function. Wow, I need to clean some of that up. Use the input function. There we go. Use the input function to store a variable. I'm going to bring this over so you guys can see it. Called my input. Note that my input is a lowercase my, a capital I in my input, which means you have to specify exactly that variable name, right? Because I told you that I needed to be that one. So don't call it name. Don't call it whatever else, call it my input. So we're going to steal this. Why? Because then I know I don't do it wrong, and set my input equal to, in this case, we're going to use what's called the input function. All right. Now, when I type this, you're going to see input and 2 parentheses. It works exactly like the print statement, only we're going to gather information from the user. So we need to specify a variable name that will end up being stored whatever the user typed into us. Okay. By default, this is just going to give a prompt on the screen with like an empty line. It's just going to sit there and blink until they type something and press enter. All right. It's best if you guys give them some kind of prompt so that they know they're supposed to be typing something in. So for example, you will see me use something like this on the screen, which is basically just the greater than symbol and telling them to type something here. All right. You don't have to do this, but it does make your program a little easier to read if you do it that way. You could also ask this question if you wanted to, right here in the prompt. Now, the difference is this will do it inline, meaning at the end of that, it's going to sit there and blink, waiting for them to type. Or the other way, like this, is going to put it on a new line waiting for them to prompt. It's better if you do this way, as far as I'm concerned. Most people get struggled if it's inline. Right? And I'll show you the difference between those two here in a second. So for now, all we're going to do is take in that input. And notice I forgot my quote. That's another thing. So notice here, when I hit enter to go to the next line, see how it kind of put it out in the middle of the next line? The reason it did that is because it's trying to keep the indentation of where I first created that double quote, which means I forgot a double quote up here. See that? So now I need to bring this line back. Now, if I hit enter afterwards, it goes clear to the left. So if you get something goofy where it's like you hit enter and you expect it to go clear to the left, and it goes out in the middle, you probably got a typo somewhere. And if you run the code, it will actually tell you where the typo is. All right. All we're going to do at this point is real quick, just print out the my input so we can see whatever the user typed in. So let's run this little simple code. I'm going to bring this over here so you guys can follow along if you choose. Come on. Okay. So over here on the left, go away. We can stop it. There we go. We got our program. And it says, hello, welcome to my program. It says, what is your name? Notice I have that little bracket with a blinking cursor waiting for me to type in. Now, if I didn't put this in here and I just had an empty input and rerun this program real quick, you'll notice it's just a blinking cursor with no prompt. So most people know that if they see the greater than symbol, it's kind of prompting for input. So you can do the greater than symbol. Some people will do a colon in there with a space, something like that. And so if we run this, notice how much cleaner it is over there for them to give a prompt. That, and if you ever watch the movie Lost, that's the prompt they use. It's a joke in a movie term. I know, I'm old, but I'm watching it right now with my wife because we got nothing better to do in the evenings. So. All right. So what is your name? I type in Jason. I hit enter. Notice it spits back exactly what I typed in. That is what this line here does. Okay. So I gather the input. The next one tells it to go ahead and just print back my input right on the screen. Now, this isn't really helpful, right? So the next line here that we're supposed to do is use the print function to print the contents of whatever my input was. Well, we just did that. And yes, I could go ahead and technically get my point just for doing this. That's not really useful, right? So let's do something that's useful and say like, you typed the following. And what this is going to do is string concatenation, in which we tell it, you type the following. Notice how I left a space here. Then plus my input. And the beauty of doing this one, if I was to rerun this one here, you'll see over here it asks for my name. When I type Jason, it gives us a nice formed product of what's going on. Everybody see the difference in there? It looks simple, but trust me, as your programs get more advanced, or even you as a user using this, the cleaner you can ask for prompt and the cleaner you can give them information, the less likely the user is to break your program and screw it up. All right. Anybody got any questions off those first couple points? Okay. So let's look at the next 2 points. And those next 2 points say use 2 different math operators from table 1-1 in your script. This may be used to manipulate some input from the user. So what this is meaning is go back to your automate the boring stuff, right? We're in here. We need to find table 1-1. So let's go look at table 1-1. There we go. There's our table. I'm saying you just need to use 2 different math operators out of this table. So for a very basic example of what that means, you could come in here and say print 2 plus 2 and print 4 minus 2. All right. Now, that will technically get you the points, but it doesn't really show you have an understanding of what those math operators are doing, right? Because we're giving those numbers and just randomly printing them out. And if I run this, it will do what we ask it to do. So let's look. What's your name? I type in Jason, and then it prints out you type the following, gives us 4 and 2. All right. It did what it asked us to do, but it would be better if we actually comprehend what we're doing with these numbers. So let's do something better than this. I really don't like seeing this on a homework assignment because it doesn't tell me you comprehend how these numbers work. So what we should do is say something like print, what is your age, right? And then we want to gather an input from the user. So let's say something like age equals input. Let's go ahead and put our fancy little prompt in there. And now we got an age from the user. Now, anytime we get input in from the user, it is always in a string format, meaning when they type in a number in here, I am going to have that in a string format. So if I say age plus 40, and I tell it to print this, right? And we could say something like this before it, say your age plus 40 equals like that. Then we go ahead and execute this code where we take whatever they typed in and add 40 to it. Let's try that. So now our program says, what is your name? Jason. What is your age? I type in 40. The program's going to crash. And the reason it's going to crash is because, yes, I typed in a number, but an input is always in that string format. So what do we got to do? Convert it, right? How do we convert it? The int function, right? So I'm going to take this part here and say int age. And what that will do is convert my age over to a number so that I can then do this plus 40 part. You could do this all in one line in a print statement, but for the sake of you guys learning, I recommend you do this in a separate line. So let's do this where it says new age equals int age plus 40. Does everybody see that? So now when I want to print that out, we could say something like actually, it's going to do it right there on the screen. We could just say print new age like that. Okay. Yeah. All right. And that's a little hard to read. I can increase that font too. You guys just have to tell me that stuff. I can't see it up there. So let's do font. And actually, I can just zoom in here a little bit, maybe. Nope. Format. Figure. Let's bump this up to 20. There we go. Is that a little easier to read? Or we need a little more?
Yes, I think a little more would be great.
Okay.
But... Okay, that's
Much better?
much better.
Okay. So on this side, what is your name? We say Jason. What is your age? I put in 40. And now it says your age plus 40 equals 80. All right. If I was to take this line here, put this above this print. Then new age, note that new age right now is an integer. So if I want to put that, say, at the end of this, where I put a space and I want to concatenate that back, note I have to convert it back to a string in order to print it or concatenate this together. So I would say string new age. And at that point, I need a single parenthesis at the end. Note when you're doing a thing inside of a function, for example, print, I am now doing a string function. When I put the last parenthesis at the end, notice it flashes black. All right. That means you completed that function. If I do it again, notice it did it to the whole print function. All right. So if I do this the first time and I notice it doesn't do the whole line like it should, I'm probably missing my second one. If I do another one and nothing happens, delete it and you're good to go. Everybody get that? When you start calling functions inside functions, it gets a little hairy. Just do a couple at the end, and when it stops flashing at you, then you can back them out of there. Real simple trick. All right. So if we run this part here, just to see if we broke any of our code, what's our name? Jason. What is 40? And now it says your age plus 40 equals 80. It's all nice and a clean line, and it gives them a nice prompt to kind of execute that stuff out. All right. Now you need to do two math operators in there. Note that this operator and this operator does not count, right? Why don't these two count? There, yeah, exactly. One is string concatenation, right? That's not a math operation. This is the only math operator we're actually doing. So if you turn this in, I only give you 1 point because you're only using one math operator. If you do another math operation, something like new age 20, and we say int age plus 20, this also won't get you the point because I wanted two different math operators in your assignment, right? So we would say something like new age 20, and maybe we say minus down here at the end. And then at this point, we could create another print statement that would say print 20 years ago, you were, and then we would say something like this, and we could just do new age, right? String. Get this right here. New age 20. And remember, we got to convert that over to a string like we did before. Okay. And so what that's going to do is take in whatever they typed in and subtract 20, and then it's going to print out these two statements. So your age plus 40 equals whatever. 20 years ago, you were blah. And so if I run this, and I type in Jason, and I say I'm 40, it's going to say I'm 80. If I add 40 to it, and it's going to say 20 years ago, I was 20. That makes sense to everybody? This shows me that you comprehend how those math operators are actually working. If you just say print 2 plus 2, that isn't useful to you. It's better that you do something like this. All right, yeah. No, because you haven't learned anything to do that yet. If you want to and you know how to do it because you played with Python before, feel free to. But just know that at this point, I don't expect it to. So, great question. What if I come in here to the run and I run this code again? It asks for my name and I type in Jason, and then it says, what's my age? And I type Jason. It's going to break, right? Because I didn't type in a number. This is okay on your first homework assignments because we're assuming the user is going to type in what we actually want them to type in. Later down the road, when I say, okay, from here on out, you need to fix it and sanitize it, at that point, homework assignment should have sanitized. But for now, you guys don't know how to do that. Okay. Last 2 points over here, because I know we're up on our time. Use string concatenation. Pretty much already done that, right? We're done. Homework assignment 1. Now, please don't turn in this homework assignment, right? Do some different math operators, do something a little bit different. And the reason I say that is if you play with it a little bit and frankly have a little bit of fun with it, it will make more sense to you in your head. If you just follow along with what I do, it's not going to click for you. The moment you start having fun with it and ask me what class I'm in, ask me something else, whatever, gather input from the user, manipulate that input in some way, and spit it back to the user. If you practice doing that, this is going to be a whole lot easier on yourself. If you do the bare minimum and get the points, great, but that's not going to help you when you get further down in the class. So in this class, write a script, have your roommate run it, have your kid run it, have whoever is near you execute your script and see what happens when they do it. All right. Especially down the road when we do need to sanitize your scripts, absolutely send it to somebody else, because what are they going to do? They love nothing more than breaking your code, right?
Yeah.
Which is great because you're going to have a chance to fix your code. So give it to somebody that wouldn't mind making you look like a fool and breaking your code, right? Because they're going to find all the bugs for you. You get so attached to your code that when it asks for an age, you're going to type in an age. They're going to type in Billy Goat and see if your program crashes, right? So for those of you that do have kids, kids love this stuff, right? They love trying to break programs, and they're going to try everything they shouldn't have. But your roommate would love to do the same thing. Somebody else around you. Trust me, anybody in this class, if you guys come early and have each other try each other's code, the more you do that, the better off you will be in this class, especially when you get to the midterm and final project. Don't be shy. Like, pretty much everybody's at the same point. That's the whole point. Okay. Remember, if you're having troubles with this homework assignment and you want me to take a look at it, you've got some error, you can't figure it out, whatever it is, you need to send me this .py file as a zip. So for example, this is all saved. I'm going to go ahead and close out of it. I'm going to bring up that folder that it is stored in. Note, you always want to save it in some folder relevant to you. Don't ever just save it right in the Python file. Because if you save it in the default Python directory, it will cause you lots of headache later on. Mostly because you're going to name it something that is a module. And when you name it as a module, it'll mess things up. So don't do that. When you come in here and I have this JSON1 homework, if you're in Windows, you can right click, go down here to 7-zip if you have it. But if you don't have it, you should be able to add to zip, send to, compress zip folder. All right. That's going to name it the same way .zip. This is what you would email me. Okay. Don't email me this because Outlook's going to block it. It's not me being a pain. It just thinks it's a virus and it blocks it. Okay. Send me the zip file. I'll go ahead and do that, which comes back in here. In order for me to grade your guys' homework, I have to grade the homework, right? Which means I have to execute your zip file. Now, I'm a cybersecurity professor. If you guys send me bad stuff that's going to hurt my machine, I will come back twice as soon. Don't do that, please. All right. It won't work out well for you and it won't work out for me. And sometimes I can get a little vindictive. So please don't do that.
Like a zip file.
Please don't do that. All right. I'm telling you, please don't do that. Jail wasn't fun. I'm just kidding. Don't do that. All right. Anybody have any questions? I do have to mention that because every now and then somebody thinks they're funny and erase format C:. It's cool. I'll come back with a whole lot better one. Just kidding. I can't do that. That's why I do air quotes because I just ruined it. Never mind. All right. Anybody have any questions on this first homework assignment? When's first homework assignment due? Sunday night at midnight. All right. When you submit your homework assignment, are you going to submit the zip file or the Python file? Python file. Zip file is only when you're emailing to me. Otherwise, please submit the Python file. It makes grading go a whole lot faster. All right. Yeah.
So I'm having a problem here. It's catching on like 20, like line 20, and here's what it's saying.
As far as the video, I'm going to go ahead and stop the video and we'll see you guys on Tuesday.